Hello, welcome to the lecture series in quantum mechanics. In the last lecture, I have discussed about the expectation value and some short trick to solve the problem on the expectation value. In this lecture, I am going to discuss some more problem on the expectation value. So let's recap what I have studied in the last lecture. In the last lecture, I have discussed some short trick to solve the problem. Means if any wave function is real or bounded, so the expectation value of p will be equal to 0. Next short trick is for any Gaussian wave function fx equal to 1 upon under root 2 pi delta x square exponential minus x minus expectation value of x whole square divided by 2 times delta x whole square. So if we calculate the expectation value of x, we can compare the given wave function psi x with the above wave function fx. Now to find the delta x means uncertainty in x, we can compare the wave function mod psi square with the above wave function fx. So in this way, we can calculate some parameter by using this short trick. So let's try to solve the problem, more problem on the expectation value. So the first problem is consider the wave function psi x equal to a e to the power minus lambda times mod x e to the power minus I omega t, where a, lambda and omega are positive constant, and determine the expectation value of x and x square. So the normalization constant minus infinity to plus infinity, psi star x psi x dx equal to 1. Now let's put the wave function. So this gives the mod of a square integration minus infinity to plus infinity e to the power minus lambda mod x e to the power I omega t, and psi x will be e to the power minus lambda mod x e to the power minus I omega t dx equal to 1. Here e to the power I omega t and e to the power minus I omega t is cancelled out, and this integral will be mod of a square minus infinity to plus infinity e to the power minus 2 lambda mod x dx equal to 1. And we know that this integral is the even function here. This integrand is the even function, so we can write 2 times mod of a square integration over 0 to infinity e to the power minus 2 lambda x dx equal to 1. So this is a simple integration. If we try to solve, this integral will be 2 times mod a square e to the power minus 2 lambda x divided by minus 2 lambda, and limit will be 0 to infinity equal to 1. Now we put the upper limit and lower limit, so we can get the mod of a square by lambda equal to 1, and here we can get the value of normalization constant mod of a equal to root lambda. Now let's try to solve the expectation value of x. This is the formula for the expectation value of x equal to lambda minus infinity plus infinity psi star x, means it power minus lambda times mod x psi into e power I omega t. Here x is the operator, and psi x is e to power minus lambda mod x e to power minus I omega t dx. Here e to power I omega t and e to power minus I omega t is cancelled out, and this integral will be x expectation value of x equal to lambda times integration minus infinity to plus infinity x e to the power minus 2 lambda mod x dx. Now if we see this, first wave function is the odd function and second is the even function, and odd into even will be odd function, limit are equal and opposite, so the integration will be equal to 0. So the expectation value of x is equal to 0. Now the next is the expectation value of x square. So expectation value of x square can be written like lambda minus infinity to plus infinity into power minus lambda mod x e to power I omega t, and here this will be x square, and e to power minus lambda times mod x e to power minus I omega t dx. This time also this and this will be cancelled out, e to power I omega t and e to power minus I omega t. So this integration will be lambda times minus infinity to plus infinity x square and e to the power minus 2 lambda mod x dx. Now this is the even function. Here we can see this is the even function. So this limit will be 2 times lambda integration 0 to infinity x square e to the power minus 2 lambda x dx. Now use this integration 0 to infinity x to power n e to power minus alpha times x dx is equal to factorial n divided by alpha to the power n plus 1. If we use this integration, so expectation value of x square will be 2 lambda equal to factorial 2 and divided by 2 lambda power 3, because here we can see n is a 2, so this will be factorial 2 upon 2 lambda power n plus 1 means 3. Now if we solve this, so this will be 2 lambda into 2 upon 8 lambda cube. This will be cancel out, 2 and lambda cancel out. So here expectation value of x square is equal to 1 by 2 lambda square. The question number 2 is a particle of mass m is in the state psi xt equal to a e to power minus alpha mx square by h cut plus it, where capital A and small a are positive and real constant. Determine the expectation value of x, x square, p and p square. So let's try to normalize this wave function. So the normalization constant is condition is minus infinity to plus infinity psi star x psi x dx equal to 1. Put the b function here. This will be mod of a square minus infinity plus infinity, and psi star will be e to power minus alpha mx square by h cut e to power I alpha t, and psi x will be e to power minus alpha mx square by h cut e to power minus I at dx equal to 1. So here e to power plus I at and e to power minus I at will be cancel out, and this integral will be mod of a square minus infinity to plus infinity e to the power minus 2 alpha mx square h cut dx equal to 1. Now if we use this integral, this will be minus infinity plus infinity x power n e to the power minus alpha x square dx. This integral will be gamma function n plus 1 by 2 upon alpha to the power n plus 1 by 2. So here in this integral, we can see that x power n, so n will be equal to 0. So this integral will be mod of a square gamma function 1 by 2 and 2 alpha m upon h cut power 1 by 2 equal to 1. After solving this, we can get here mod of a square pi h cut upon 2 alpha m power 1 by 2 equal to 1, and the value of normalization constant will be 2 alpha m upon pi h cut power 1 by 4. Now let's try to calculate the expectation value of x. So the expectation value of x can be written as integration over minus infinity plus infinity psi star x psi x dx equal to expectation value of x. So this integral will be under root 2 alpha m upon pi h cut integration minus infinity plus infinity and x, and this will be psi star x psi x. So this will be e power minus 2 alpha m x square by h cut dx. Now here we can see x is the odd function and e to power minus 2 alpha mx square by h cut is the even function. So total x and e to power minus 2 alpha mx square by h cut is total odd function, and limit is equal and opposite. So the expectation value of x will be equal to 0. Similarly, we can calculate the expectation value of p, and we can use the shortcut because here we can see the wave function is a real wave function. So if the wave function is real or bounded, so the expectation value of p will be equal to 0. So the expectation value of p will be equal to 0 in this problem. Now let's calculate the expectation value of x square. The expectation value of x square can be written as under root 2 alpha m upon pi h cut e to the power minus infinity to plus infinity x square e to the power minus 2 alpha m x square by h cut. Use this formula, x power n e to power minus alpha x square dx limit minus infinity plus infinity. So this will be gamma function n plus 1 by 2 upon alpha power n plus 1 by 2. Here n is equal to 2. So use this integral. This integral will be under root 2 alpha m upon pi h cut gamma function 3 by 2 upon 2 alpha m h cut power 3 by 2. After solving this, this will be x square expectation value of x square equal to under root 2 alpha m upon pi h cut. This will be 1 by 2 into root pi and 2 alpha m upon h cut power 3 by 2. So after solving this, we can get the value of x square, means expectation value of x square is equal to h cut upon 4 alpha m. Now let's try to calculate the expectation value of p square, and the expectation value of p square is minus h cut square under root 2 alpha m upon pi h squared integration minus infinity to plus infinity e to the power minus alpha mx square by h squared, and p square means h squared square d square upon dx square. So here this is the b function also, and e to the power minus alpha mx square by h squared square into dx. Now if we double derivative of this, so this alpha m by h squared is comes out outside, and the b function is as it is. So this first term and this is the b function term is as it is, and if we do the second derivative of this b function, so we get the alpha m by h squared. Now after rearrange this, equation will be p square equal to minus h squared square under root 2 alpha m upon pi h squared integration minus infinity plus infinity e to the power minus alpha mx square upon h squared alpha m by h squared e to the power minus alpha mx square by h squared dx. Now if we solve this, so this will be e to the power minus 2 alpha mx square by h squared, and this alpha m h squared is comes out here because this h squared and this h squared is cancel out. So this will be alpha h squared m, and all that this constant term is as here we can write as it is, and this is the gamma function integral. We can use this gamma function integral, and we can see that x power n, here n is equal to 0, so this will be gamma function 1 by 2 upon 2 alpha m upon h squared power 1 by 2. After solving this, expectation value of p square will be alpha h squared m under root 2 alpha m upon pi h squared, and this will be under root pi 2 alpha m h squared power 1 by 2. So this will be cancel out, this term and this term will be cancel out, and here we can see the expectation value of p square will be equal to alpha h squared m. So we can calculate the uncertainty also. And we know that the uncertainty can be written like under root square average minus average square. So this is the expectation value of x is equal to 0, and the expectation value of x square I have calculated this. So this will be under root h squared upon 4 alpha. Similarly, uncertainty in p can be written like under root expectation value of p square minus uh, expectation value of p whole square. So this will be expectation value of p will be equal to 0, and here we can calculate alpha h squared m. So this will be under root alpha h squared m. Now the uncertainty product delta x into delta p can be written as under root h squared upon 4 alpha m into under root alpha h squared m. After solving this, we can get here delta x into delta p is equal to h squared by 2. So this uncertainty product is exactly equal to h squared by 2, and this is because the wave function is a Gaussian. For the Gaussian wave function, the uncertainty product is exactly equal to h squared by 2, and for any other wave function, this will be greater than equal to h squared by 2. Now the third problem is a particle is given by wave function psi x equal to a into a square minus x square. This will be minus a2 plus a, and otherwise wave function will be 0, and determine the expectation value of x, x square, p and p square. Now let's try to solve this. So first we have to we have to calculate the value of a. This is the normalization constant. So this will be minus infinity to plus infinity psi star x psi x dx equal to 1. After the after putting the wave function, so this will be mod of a square minus a2 plus uh, a square minus x square to whole square dx equal to 1. Now if we this can be written like a square plus b square plus 2ab. So here limit is equal and opposite, and this wave function is given. So this can be written like 2 times mod of a square 0 to a. So this will be a to the power 4 x to the power 4 minus 2ax square x square dx equal to 1. Now if we integrate this, so this integral will be e to the power 4 x, here this integral will be x power 5 by 5 and minus 2a x cube by 3, and if we put the upper limit and lower limit, so this integral will be 2 times mod of a square 1 plus 1 by 5 minus 2 by 3 equal to 1. So here we can calculate the value of mod of a. So this will be 15 by 16 e to the power 5 power 1 by 2. This is the value of normalization constant. Now once we get the value of normalization constant, we can calculate the expectation value of x. So here we can see this is the expectation value of x will be 15 by 16 a to the power 5 minus infinity plus infinity x a to the power a square minus x square whole square dx equal to 1. So here we can see x is the odd function and this will be even function, and total b function will be odd function, limit is equal and opposite. So the expectation value of x is equal to 0. Similarly, we can calculate expectation value of p, and we know that this b function is a real, and so the expectation value of p will be equal to 0. Similarly, we can calculate expectation value of x square, and expectation value of x square can be written as 15 by 16 e to the power 5 minus infinity to plus infinity x square a square minus x square to whole square dx equal to dx. Now, if we solve this, because this is an even function, so limit will be 2 times 0 to a, and here 15 by 16 is as it is, and if we do a square of this function, so this will be a to power 4 x power 4 minus 2a square x square dx. Now, uh, yeah, after solving this will be 15 by 8 and a to power 5, because here 2 and 16 is cancelled out. So this will be 8 power 4 x cube by 3 x power 7 by 7 minus 2a square x power 5 by 5, and the limit is 0 to a. After put the value of the limit, so this will be 15 by 8 e to power 5 8 power 7 by 3 plus a power 7 by 7 minus 8 power 7 by 5. So here a to power 5 and 5 cancel out. So this will be 15 a square by 8 1 by 3 plus 1 by 7 minus 2 by 5. After solving this will be 15 a square by 8, and this will be 10 by 21 minus 2 by 5. So here this will be 15 a square by 8 into 8 by 105. Here 8 and 8 cancel out, and 15 and 105 also cancel out. So the final result will be expectation value of x square equal to a square by 7. Now expectation value of p square also we can calculate here, and expectation value of p square will be 15 by 16 a to the power 5 and minus a2 plus a square minus x square minus h square del square upon del x square. This is the p square, and a square minus x square dx. Now after taking double derivative of this, so this will be a square, and this will be 2 times x minus 2x, so minus 2 will be into dx. So this will be minus 2h square into 15 by 16 in power 5 and 0 to a, because this is the even function and limit will be equal opposite. So this can be written like 2 times. And here we can see that this is the b function a square minus x square. After that, taking the double derivative, so this comes out minus 2 and into dx. Now after solving this will be 15 h square by 4 e to power 5 integration 0 to a square minus x square dx. Now after doing the integration, this will be 15 h square by 4 e to power 5 a cube minus a cube by 3. Now after solving this will be expectation value of p square equal to 15 h square by 4 a power 5 2 a cube by 3. After simplifying, the expectation value of p square equal to 5 by 2 h square by a square. Now the uncertainty product can be also calculated here, because the expectation value of x and expectation value of p will be equal to 0. So only expectation value of x square and expectation value of p square contributed in the uncertainty product. So this will be a by root 7 into under root 5 by 2 h cut by a. After solving this will be under root 5 by 14 h cut by a. So if we solve this will be greater than by h cut by 2. So in this way, we can calculate the expectation value of any problem, uh, or expectation value of x, expectation value of p square, or the uncertainty product. So this is all about the expectation value, and I have done the conceptual part and some problem on this also. So uh, Thank you for being with us.